Hi there, and welcome to the first lecture of our Chapter 3 unit all about Pythagorean relationships. So to start us off, we are going to look at 3.1 and talk about squares and square roots. So we have some keywords here, some definitions that I would like you to learn and understand. And the first one is a prime number. What is a prime number? Well, that is simply a whole number, so not a decimal, a whole number that is greater than 1. So not 1, but something bigger than 1 that can only be divided by 1 and itself. For example, 2 can only be divided by 2 and 1. 3 can only be divided by 3 and 1. 5 can only be divided by 5 and 1. 7, 13, 11, 17, and 19 are all examples of prime numbers. Now we can factor prime numbers, and that is simply a number written as a product. So remember that product is multiplying, and we're talking about the product of the prime numbers. We use this often in factor trees. For example, if you have 6, for example, and we want to factor that down, we can say, well, 6 can go down to 2 and 3. 2 times 3 is 6, and we know that 2 and 3 are both prime numbers, so that would be prime factorization. We also are going to talk about perfect squares, or numbers that can be a square number, and that is simply a number that is a product of the same two factors. So for example, some common perfect squares would be 1, 4, 9, 16, 25, 36, 49, there's lots, 64, 81, 100. Here are all the common ones we're going to look at, 121, 144. So basically, these numbers are just the answer when you multiply two of the same number. So if you multiply 1 times 1, you get 1. If you multiply 2 times 2, you get 4. If you multiply 3 times 3, you get 9. Oopsies. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, etc. So you see that when you times the same number by itself, then you get a product, and that would be considered a perfect square. Alright, well, the square root then, the last definition, that's just the opposite. A number that when multiplied by itself equals a given value. For example, 5, and if we multiply this number by itself, so 5 times 5, it gives us the number 25. So if we say what's the square root of 25, that would just be 5. So we represent the square root with this symbol here. It's kind of like a check mark with a line over top. Alright, identifying perfect squares, let's determine the prime factorization of these numbers. So 24, how can that be broken down? Well, something times something equals 24. And so for example, let's say 4 and 6. Can these numbers be broken down into just prime numbers? Well, 4 can be broken down to 2 times 2, and 6 can be broken down to 2 times 3. So 24 equals 2 times 2 times 2 times 3. Okay, let's try 36. 36 we can go a couple different ways, so I'm going to write it again over here. The first way, we'll say 4 and 9. 4 times 9 equals 36. 4 can be broken down to 2 and 2. 9 can be broken down to the prime numbers of 3 and 3. So 36 equals 2 times 2 times 3 times 3. Or you could say, well, I also know that 6 times 6 is 36, and 6 can be broken down into the prime factors of 2 and 3. So this is the same answer, 2 times 3 times 2 times 3, because it doesn't matter what order you multiply it in. So it doesn't matter which way you do your factor tree, as long as you just end up with prime numbers at the very bottom. So which of these numbers listed here are perfect squares? Well, we know that 4 is a perfect square. 2 times 2 is 4. We see that here. We see that here. We also know that 9 is a perfect square. We see that here. The same number multiplied by itself. 3 times 3 equals 9. And we see in our extra example that 36 is a perfect square because 6 times 6 equals 36. Whenever you use the same number, that number times the same number, then you get an answer that would be a perfect square. So if we were to draw these perfect squares on this grid, then I'm going to use just a different color here. Then we could say that 2 times 2 gives us 4. So if I make that a little thinner, this is 2 blocks up and down, this is 2 blocks sideways, and so this gives us 4 blocks in the middle. What about with our 9? Well, 9 is 1, 2, 3 times 1, 2, 3. So we have here 3 times 3 gives us 9. And last but not least, we have 36 is just 1, 2, 3, 4, 5, 6 blocks down, and 1, 2, 3, 4, 5, 6 blocks across. And if we do 6 times 6, we get 36. All right, let's move on to our next side. So let's try some of these examples here. Determine the area of a square picture. So we have a square, so all the sides are equal. To show that the sides are equal, I like to do these little lines. So that means that all the sides are the same, and each side is 13 centimeters, it tells us. And let's make it a picture of a smiley face. All right, so we already know that the area of a square, or an area even of a rectangle, is length times the width. But in this case, because all the sides are the same, the area then is just the length times another length, because they're all the same. If this is the length, the 13 centimeters, so something times itself you can express as length squared. So the area of this square is the side squared. So let's plug in our value of our length. Our length is 13 centimeters squared because it's 13 across and 13 up and down. So 13 squared, 13 times 13, the area is 169 centimeters squared. All right, let's try another example. What is the side length of a square with the area of 144 centimeters squared? So this square has all the same sides, but the area is 144. So let's write down what we already know. Area equals length times width, but we know that the length equals the width for a square. So we just have area equals length times length, area equals length squared. And we know that 10 squared equals 100. So, and we want, this would be the area. So 10 squared, 10 across and 10 up and down would give us 100 for the areas. And this is a little bit more than 100, so probably we're looking at an area, if we're just going to guess and check, of about, I don't know, 12-ish. So let's try it. If we plug that into our calculator, 12 squared, what do you get? So on your calculator there is a button, and the button looks kind of like this. The button has an X and then a square, a little 2 on top of it. If you type in 12 on your calculator and then hit that button with the X with the 2, then that will give you the answer, and our answer here is 144, and that is correct. Hooray, we did a good guess. But you can do this another way. You can also factor it out. So 144 is, if you divide that by 2, it's 72 times 2 will give you 144. Is 2 a prime number? Yes, it is. So we can just drag that down. 72 can get broken down into two numbers. 8 times 9 equals 72. Are those prime numbers? No, so we need to keep going. 8 can be broken down into 2 times 4, and 9 can be broken down into 3 times 3. Are those all prime numbers? Well, 2 is, 4 is not, 3 is, and 3 is, so this needs to get broken down a little bit further. 4 can be broken down into 2 times 2. Let's bring all these down. So 144 is the same as 2 times 2 times 2 times 2 times 3 times 3. And if you just rearrange that a little bit, you could say it's the same as 2 times 2 times 3 times 2 times 2 times 3. Because we have 4 2's and 2 3's, 1, 2, 3, 4 2's and 2 3's at the top. So I just moved the numbers around a little bit. And if we look here at these two sections, they're the same. 2 times 2 times 3 is the same as 12. So this is the same as 12 times 12. We know that that is the same as 12 squared. So 12 squared equals 144. The square root of 144 then is 12. All right, let's try our last example with the calculator. All you have to do is plug it in. So we know the area equals L squared. So if 144 equals L squared, then we want to figure out what just L is. We don't know what L is, that's the unknown. So the square root and the square sign are the opposites. So kind of like how multiplying and dividing are the opposites. If you want to make a number equal to 1, then you would divide that number by itself. So same kind of thing here. If you want to get rid of this guy up here, you just put a square root sign on top of it. But whatever you do to one side, you have to do to both sides. Okay, so the square root of 144 equals, well, the square root sign and that squared number cancel out, so you just get the L. So the square root of 144 equals L. If you type into your calculator the square root of 144, sometimes they're different. Sometimes you have to do the square root button and then the number. Sometimes you do the number and then the square root button. It just depends on your calculator. But for me, it looks like this on my button. You may even have to press that shift arrow first, because your button might look like this with the little guy up there. So then you'd have to press shift and then your button like that. So here I'm going to type in 144 shift, and I see that I get 12. And that is the same answer we've been getting, so we know that it's right. Alright, I hope you're now feeling comfortable with squares and square roots. We are going to practice this more in class tomorrow.